Hi, this is Roger from Kanka Labs. Now with finally the first battery charge tester from eBay that has all the features and all the functionality that I was seeking for. So let's first of all take a little overview, what's about the user interface, what's on the top side, what's on the bottom, and then finally, let's test the accuracy of this thing. Now, first thing you can see, this thing has 4-wire Kelvin connections. So you have separate connections for measuring the voltage of your battery directly at the battery. And thereby, this thing can also calculate the internal resistance of your battery. With the last big 100 watt tester that I showed you, there was also an ohms display on the LCD, but that was the load impedance or resistance. And here it's the internal resistance of your battery. So quite a nice feature to have this 4-wire connection. You don't have to use it, so you can leave the voltage connection here, you can leave it out, but if it already has it, we will test it. So next, by the way, this thing sells as TEC-06 on eBay, so search for that with TEC-06 battery charge tester and you certainly will find this. It costs around $10 or euros, plus minus a few. Next is a little cooling fan for the MOSFET or bipolar transistor. I tried to unscrew it, but the power transistor is so heavily glued and screwed to the little heatsink here below the fan that I didn't want to exert too much force so that we still can test this before the power transistor breaks down. So I can't tell you at the moment which transistor they're using. Anyway, that's not of such a great importance. As you can see from the small size, this is certainly not designed for big powers. It's rated for a maximum of 3.5 amps discharge current and a maximum of 15 volts. And a maximum power dissipation of 16 watts. So if you halve these values, you're certainly on the safe side. One little mod I did, what you should always do, if you have colored displays, apply a piece of plastic translucent film in the same color as the display, so the contrast and the readability of the 7-segment LED display plus the red diodes is much improved, not only here on camera, but also in real life. And the next thing you can see here from the 5 display values, the 2 middle ones here were only in Chinese, so I added a little label so that I always know what it is. And you can see, you can cycle with the little rotary encoder with a indent push button through 5 different values. First is of course the measured amp hour or milliamp hour value. Then comes the battery voltage, designated here with a U for volts. That's the actual measured voltage. Then you can set the cutoff voltage just by pressing the push button on the rotary encoder and then set it in 5 millivolts steps, going from 0.9 volts as a minimum, I think up to 12 volts or something like that. Oh, we can try it out. Let's see how far we get. As you can see, the fan is not running. It also only turns on when the dissipated power becomes greater than 2 watts or something like that. So how far do we get? Yeah, 12 volt is the maximum. So ideal for testing lead acid batteries. So let's turn this back again to 1 volt because I've connected a little AA rechargeable nickel metal hydride battery. Okay, push again and we can further cycle through. Next is the milliamps setting for the discharge current. The minimum is 50 milliamps. I would have liked to get a little bit lower, but 50 milliamps is okay. It's a little bit too much when it comes to testing lithium coin cells or alkaline coin cells, but anyway, we have to live with that, and it goes up in 50 milliamps fixed steps, and I think from 500 milliamps it goes in 100 milliamps steps up to 3.5 amps. So that's quite okay. Let's get it back again to 50 milliamps, simply because the problems we had until now with all the other tested battery charge meters were especially with an offset in the lower range. So we will see how accurate the 50 milliamps is. The claimed accuracy is better than 1%. We will see if this is really true. And the last setting is for the measured internal resistance of your battery in milliohms. And so to start this, you go to the uppermost position, press shortly on the push button, and when the LED is then blinking, it is just measuring, and we will later see how accurate this thing is. So there's also a mode where you can automatically cycle through all the values. Just when you're in the milliohms mode and you shortly press the button, then it will display all 5 values in sequence. So, and as you can see, this thing needs an external 5-volt power. There's a mini USB connection, and I would not advise this to connect it to your PC. It draws 240 milliamps, and a Windows PC then recognizes this and will try to install a driver. But because, of course, there are no data sent, this fails, and you always get this Windows sound for a failed driver installation because the USB device doesn't answer, etc. So it's better to have an external 5-volt power supply, a charger. Anybody of us has something like that lying around. So let's stop this thing for a moment and take a look at what's on the lower side of the PC. So this could be the original manufacturer, Shunda Electronic, I don't know. What we see here is apparently they have paralleled 4, I think, 0.33 ohm resistors as current measuring shunt resistors. So that's quite a nice idea, not to have a too low value. The usual 50 or 100 milliohms or 10 milliohms, depending on the current you want to measure, the usual 2 or 4 wire shunt resistors, they are so low that the offset of your op-amp with which you have to amplify the low voltages here becomes significant. And here they obviously use the good old LM324. I don't think that you can see it very good depending on the lighting. So anyway, even marked as an original Texas Instruments chip. I don't know if it's really a genuine TI chip, but at least the label suggests it. And we have an LED driver, the TM1620, which was also, as far as I remember, used in the very cheap and non-usable battery charge tester. And as a microcontroller, they have an STC12C5608AD. That's an 8051 derivative with a 10-bit ADC, 8K flash, but it doesn't have an internal reference. And I couldn't discover if they have an extra precision reference. Q2 must be a transistor. Perhaps this U4 is either that could be a reference diode. I couldn't decipher the marking here of find out what this thing really is. But this could be an external precision reference. Well, we'll test the accuracy anyway just in a minute. 2 protection Schottky diodes, and that's all. And you don't need anything more for a good battery charge tester. And we could see there's a quartz crystal, so we can be quite sure that the timing is very accurate. So this will be no problem at all, and not with all the others, which only rely on their internal RC oscillator. So at least with using a quartz crystal as a time base for the microcontroller, they have eliminated any inaccuracies concerning the time measurement. So now finally let's test the accuracy and see how good this thing really is. So, okay, let's see. First thing, the battery voltage. The displayed values is 1.24 volts. True value is 1.27. So that is 30 millivolts out, which is not bad. And because the voltage measurement, or the accuracy of the voltage measurement, is of minor importance, we will just note this down because we will later need it in the calculation of the internal resistance, if this is really correct. Cutoff voltage we have set to 1.00 volts. We start with the lowest settable current of 50 milliamps. As you can see, I've connected here the single AA cell with 1.25 volts nickel metal hydride rechargeable. And okay, so let's start this thing. And what you can see, the current was slowly ramping up, and they claim in the description that they have a precise control loop. So it really seems that the microcontroller, and from time to time it goes down, so the control loop starts cyclically again, and it settles finally to very near 50 milliamps. I've especially used here the 10 amps measurement range for having a low shunt resistance in the current path and not using the milliamps mode. So if we rely on this X-TEC multimeter, which is quite exact, we are so near to 50 milliamps that we can call this bang on. And the voltage has dropped to 1.22 volts. So now let's first of all calculate what the internal resistance should be. So we start with our 1.28 volts rounded without a load, subtract the voltage present now, which is 1.22 volts, and if we divide that by our 50 milliamps load current, we would get 1.2 ohms as internal resistance. Let's see what we get displayed here. Well, this is not so good. It says rounded 700 milliohms or 0.686 ohms. So that's a little bit off, but this could be due to changes in the voltage. It's not so important, so I will check this later again and tell you what I found out. Anyway, because I didn't start the timer, we have to reset again with a long push of the button. Okay, that was it. First you have to stop, then 2 seconds key press, and let's start the timer now in sync, more or less in sync. Okay, and it has ramped up again. You can see that that there really must be a software control loop, or probably a software control loop. So to get a measurable results of, let's say, 100 milliamps hours, where we can check the accuracy, of course at these low currents we have to wait for a few hours. So I will leave this running and come back when we get a result in the 3 digits region. So, sorrily, the battery of my camera failed exactly in the moment when the 2 hours were reached. So I stopped the discharge process exactly at after 2 hours, and we should get 100 milliamp hours when we had 50 milliamps discharge current, and we get exactly this result. It jumped from 99 to 100 milliamp hours at exactly the moment when 2 hours had passed. So this thing seems to be really accurate to 1%. I never would have believed this beforehand, especially at this lowest current setting of 50 milliamp hours. So I'm very happy with that and very surprised with the result. Now what's still missing is now that we go to higher amps and test the upper range in the range of 2 to 3 hours. Therefore I will rewire this thing and put either a lead acid battery or 4 AA's to this device, and I'll be back in a minute. So I've taken out my 6 volt 1.2 amp hours lead acid battery, and let's see what we get. The measured voltage 6.3 volts, that's quite exact. I've set the cutoff voltage to 5 volts. And now we go to a beefy 2 amps, beefy for this little thing and this battery. And let's see what we get, while at the same time, now I have to be quite exact to hit the start button of the stopwatch at the right moment, because the milliamp hour counter will ramp up quite quickly. So, and the fan is turning on, and we're ramping up to nearly exactly 2 amps. That's very astonishing. Now the voltage directly at the battery has dropped to 5.78 volts. So this is about half a volt less, and let's see what we get. That's a little bit strange. I think there's something wrong with the 4-terminal measurement. Why is it displaying 6.09 volts? So the voltage can't be 6.07 volts. It must be lower. So I don't quite understand. There's something wrong with the 4-terminal measurement. So anyway, we had half a volt of voltage drop when the current turned on, and this should give, by Ohm's law, an internal resistance of half a volt divided by 2 amps. This should be 250 milliohms, and let's see what we get displayed. Oh, we get only half of that value, just as before. So auto power off is always a bad thing. So I think there's something wrong in the 4-terminal measurement. My suspicion is that because this is nearly exactly half of the value that it should be, that here the minus terminals, they are not truly isolated. The right way you would do that is put a true differential amplifier here at the plus and minus terminals of the voltage measurement. And I think there's something wrong in the circuitry, how they realized the 4-terminal measurement. Anyway, that's of no big importance, simply because to me this is really of minor importance. And we're already 104 milliamp hours. So let's run this thing a little bit longer just to get a more exact value and see if it withstands the 2 amps for an extended time period. Let's see if I can. Yeah, it gets a little bit warm but barely recognizable. So what is it dissipating now? 12 watts. That should be no problem with the fan. Without the fan, that would really be a problem. So if the fan fails, then this thing will quickly die. At least the power transistor will quickly die. In the meantime, I've thought a little bit how they realized this control loop. As you can see, that periodically here, like here, the current goes a little bit down and then is readjusted again to 2 volts. Perhaps they are doing they are using the PWM output of the microcontroller with a little RC filter and doing that control loop in software. It's certainly not done in hardware as in the other battery current charge testers that I investigated. So anyway, this thing looks really good. Let me just think, after 6 minutes, which is the 10th of an hour at 2 amps, we should get 200 milliamp hours. So let's stop this thing exactly after 6 minutes, which we have reached just in 45 seconds. And it looks that the result comes out again bang on. So that was exactly, I was a little bit late, but that was exactly 200 milliamp hours as it should be after exactly 6 minutes. So the accuracy is really in the range of 1%. We could of course take a longer measure, but 1% is more than enough for measuring the capacity of batteries. So this thing is near perfect. Forget about the milliohms measurement, the internal voltage. So look, without any load, except for, whoops, that's how it looks like without the little red transparent film overlay. Without any load, the voltage is quite exact, but when the load is turned on, then the voltage is really completely out. Let's get back to voltage. So you see, it's only half the voltage drop it should be, and well, not important for me. So the final verdict for this little $10 or euros battery charge tester is really, I would recommend it. I would give it a thumbs up, and if you liked this video, then please also give it a big thumbs up. And that was it for today, for finally a good and usable, small, cheap battery charge tester. Thanks for watching. Until next time, bye from Roger, bye from Kanka Labs.